our discussion on calculator techniques na pwedeng gamitin sa ating Canon calculator. So, we will be discussing topics on refrigeration and apply those principles and concepts na natutunan natin previously and use that to solve our succeeding problems. So, let me read first the problem. In an ammonia condensing machine, the water is used for condensing is at 55 degrees Fahrenheit and evaporator is at 15 degrees Fahrenheit. If 1.5 horsepower per TR, tons of refrigeration, is required, what is the actual COP of the system? So, pag sa problem nagpapahanap ng actual COP, what we really need to think of is yung equation regarding our COP. So, since we are considering yung cooling, since meron tayo ditong condensing machine, then our COP will be most likely related sa QA over yung work ng compressor natin. So, this is our equation na gagamitin. So, heat added over our work of the compressor. So, if yung problem, nagpapahanap ng actual COP, then, and in the problem given din yung natawag na power per ton, then we can relate that power per ton dun sa COP natin. So, paano natin sir nalaman na may power per ton? So, may binanggit kasi na 1.5 HP per ton sa refrigeration. So, that is what we call power per ton. And the power per ton is the work of the compressor divided by the QA or yung heat added natin. So, what we can observe from these two equations or two relations is that yung isa, QA over work ng compressor, yung isa naman, work ng compressor over QA. So, kung papapansin, baliktad lang sila. Inverse reciprocal. So, therefore, from that, we can relate na yung COP is simply 1 over the power per ton. And since this is a problem given tayo ng power per ton, we can simply substitute it to the equation. However, diba, etong sinubstitute natin na 1 over 1.5 HP per ton sa refrigeration is hindi yan yung hinahanap nung nasa question natin. Since ang unit is naka-TR pa tapos may HP, we need to cancel those out, yung mga units natin. Kasi ang COP, as we know, should not have a unit. So, iangat natin yung tons of refrigeration sa numerator and yung HP retained sa denominator. So, we will convert tons of refrigeration and HP into a unit na pareho in a way na makakancel yung dalawa na yan. In other words, let us try to convert tons of refrigeration muna into kilowatts. So, we know that 3.52 kilowatts is 1 tons of refrigeration. 1 horsepower is 0.746 kilowatts. So, maka-cancel out yung kilowatts and cancel out din niya itong ating horsepower pati yung tons of refrigeration. In turn, yung makikita nating units ay magiging wala na. So, that perfectly fits doon para sa ating COP. Ang gagawin na lang, compute na lang yung COP para sa calculator natin. So, yung nasa taas, that is 3.52. So, divided by, then yung nasa baba naman is 1.5 times yung conversion nga natin na 0.746. So, simply press equals then FD for our COP. What we would get is 3.8. From the choices, ito yung letter C natin. Sige, so let us also discuss other problems sa ating refrigeration with regards sa ating concepts na commonly ma-encounter natin and we will be much more working with since we are taking the board exam. So sometimes trivial ideas like this should be important to us. So let me read the problem first. A 23 tons refrigeration system rejects heat at 100 kilowatts. So calculate the energy efficiency ratio of the system. So ang hinahanap lang dun sa problem is yung tinatawag na EER or yung energy efficiency ratio. So sa EER, actually EER is basically same concept sa COP. The only difference is yung units na ginagamit. So, Ang ER is basically COP, but ang units nito ay naka-BTU kilowatt hour, di ba? So in that way, meron siyang additional conversion factor which is 3.412 COP. Ayan yan yung conversion factor natin. So in electrical units kasi, yung COP hindi nila masyadong nare-relate in terms of electrical power, di ba? So in order to relate thermal unit ng heat sa electrical power, they use some kind of conversion. So and basically that's just conversion factors. Anyway, ang point natin dito is that ER is the same as COP, and we'll just multiply some factor which is 3.41. So we know that COP is heat added over work ng compressor if it's cooling, di ba? So since binanggit naman refrigeration system, then cooling yung application. Yun nga lang sa problem, kung papansin, so sorry, yung QA natin is given. Since binanggit naman tons of refrigeration, kung sinabing tons of refrigeration, that is heat added. However, yung work ng compressors hindi binigay. Instead, ang binigay, yung rejection ng heat ng ref system natin, which is at 100 kilowatts. So in other words, ang given sa atin dito ay QA tsaka QR, pero ang kailangan natin work ng compressor. So we know, pag yung system natin is a refrigeration, yung work ng compressor is basically the QR minus QA, di ba? And since etong QR is given, yung 100 kilowatts, as yung QA yung 23 tons of refrigeration system, then we can solve yung work ng compressor. So ito, substitute lang natin tong QA, QR, tsaka QA. Diba? So when we do that, solve na natin ER para diretso na since isang lagay lang naman yan. So this is 3.412 times yung COP. QA, that's 23 tons of refrigeration divided by work ng compressor which is QR, 100 kilowatts minus QA na 23 tons of refrigeration. So before we compute this, we know that yung tons of refrigeration tsaka kilowatts hindi pwedeng magsama. So i-convert natin yung mga units na yan. So for simplicity, ang i-convert natin itong kilowatts, palitan natin ng tons of refrigeration. So from the concept, we know that 3.52 kilowatts is 1 tons of refrigeration. So divide mo yung kilowatts tapos multiply yung tons of refrigeration. And when we do that, yung kilowatts magka-cancel out, tapos TR na yung numerator and denominator. And that will also lead us to cancel those outs, di ba? So pag meron na tayong to, pwede na natin computean yung ER natin. Sige, so kunin lang natin yung calculator, then put yung mga values na kailangan natin. So always remember na when we are dealing with refrigeration system, yung QR natin, yun na yung pinakamalaki out of dun sa tatlo, which is yung work net tsaka yung QA. So it's always yung work is QR minus QA, which is very different, di ba, pag engine, which is QA minus QR kapag engine. So baliktad siya kapag refrigeration. In any case, yung makukuha nating ER is 14.51, and basically ito yung answer natin, yung letter B.